Quite some time ago, I built a GBS-Control, and I did say that at some point I would come back and maybe add some of the additional peripherals. So this is a revisit of that GBS-Control to fit the clock generator. The clock generator, in theory, should solve some of the problems with video signals. The clock generator is controlled over I²C. The instructions for this don't seem too bad, and it looks like with my board, it's actually going to be a little bit easier to fit. The clock module itself comes with a few parts that I don't actually need. All I need is this little board. The clock signal goes into the video controller chip. I'm also going to leech some power from a nearby pin. After securing the power and clock signal with hot glue, I realised that I'd in fact soldered the power to the ground side of the capacitor.
Shit.
So that will need to move.
It was early. Well, it was definitely before 10, and my coffee was still hot.
We've got a leak.
I've heard that before. Last time it cost me a new roof.
Not that sort of leak. Designs, my good man.
A little later, a brown envelope slid under my door. Schematics, Gerbers, parts lists, complete projects. Somebody was giving away enough information for you to build these yourself. This case felt like it had more missing pieces than a Las Vegas expense claim. Everything pointed back to PCBWay. Their shared projects section was filled with designs uploaded by makers from all over the world, ready to discover, share, and build. And even then they were still able to provide prototypes for as little as $5.
The other two connections we need are to the I²C bus. Those are picked up from the original microcontroller on the board, which is a PLCC package, so these aren't too difficult to connect. Adding some more hot glue to stop the wires from moving. We can now turn our attention to actually connecting everything to the board. I've already soldered the I²C bus off camera, apologies. So we just need to connect the clock signal and power. The clock signal goes to the central pad of clock 0. And the power just goes to the top of this capacitor. This is a 3.3 volt power supply. Probably are other places I could have got this from the board, but I'm following the instructions. I'm now going to use solder mask tape to just wrap this thing up to stop it shorting out. adding some additional tape to the heatsink itself, again to stop anything shorting out. Well, the final part that I didn't film...
Press record! Press record!
I have no idea how I've managed to miss filming this part. The board itself is connected through the ground connection, and all I've done is add a pin header and then solder the clock generator on top. Now it's all connected up, we just need to try it. Connecting power, it seems to power up without any problem. So the next steps are to connect it to the HDMI and attach it to something that can provide a video source. This Amiga 600 should do nicely. Going to the footage from my original video, it does look to be a much cleaner video signal. And Roadcraft is showing it its loading screen and its menu without any problems at all, and it is pixel perfect and very sharp. The question is, where do I go from here? There are other things you can connect, like rotary encoders and OLED displays. I'm not entirely sure what advantage they would give me over what I've got now, as I control it from inside OBS using the standard web interface. So if you found any part of this video useful or entertaining, then please consider clicking like. And why not subscribe to the channel? And in the meantime, why don't you check this out next?